All right, ladies and gentlemen, so today we're going to be looking at function notation in a graph or a table. So we did function notation in equation form, and now we're going to be taking a look at it in a table. So when I have this, so here we're talking about boiling water at 212 degrees Fahrenheit is left in a room that is at 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and given in the table below. In this scenario, temperature T is a function of the number of hours, meaning the temperature depends on how long the water's been sitting there. Right? That's what a function means. It depends on. All right. So when they're asking you to evaluate, you're really just pulling information off of this chart. So if I want to evaluate T of 2, well, that means 2 hours. What's the temperature? Well, if I look right here, right, at 2 hours, the temperature is 104 degrees. So T of 2 would be 104 degrees. T of 6 means, well, after 6 hours, what would the temperature be? And that one's going to be right here. So T of 6 is equal to 68 hours. Or 68 degrees, sorry about that. Okay, well, now let's see what else they want us to do. What value of H is T of H equal to 76? So now they're saying, here's the temperature, right? That's the temp. I want to know how many hours did that take? Well, there, oh, I circled the wrong one. Okay, let's try that again. So here's my 76 degree temperature. The hour, H, would have to be 4. All right, between what two consecutive hours, remember consecutive means in order, will T of H equal 100? Well, you have to kind of look at your chart. So here's 104, here's 85, so it's going to be between 2 and 3 hours. Okay, let's talk about how we can read and get information from our graph. So here's this graph that looks like, what the heck is this, right? It's piecewise, right? Piecewise means that it's made up of pieces of straight lines. We have one straight line here, we have one here, 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 so on. So they're different pieces. Okay, well, what does this mean? This means that when they're asking it in this way, the number inside the f of 1 means your x value. So we're going to be looking at our chart. So if I want f of 1, well, here's where x is 1, and I'm going to read up, which means 1, 2, 3, 4, that equals 4. If I want f of 5, so I'm going to count over to 5, 1, 2, 3, 4, 5, and I go down, that one's equal to -2. F of -3, right, so over here we have 1, 2, -3, and I'm going to go down, 1, 2, 3, 4, -4. F of 0, right, so here's where it's 0, is at 2. So it's reading points off of a graph. Solve each of the following for the values of the input of x. So kind of again, going backwards. Let me erase some of this off of here. So as I'm going backwards, right, f of x equals 0. I want to know what values of x would give y of 0. Well, those are right here, here, and here. So you actually have 3 of them, and that's okay. We have x equals -1, x equals 4, and x equals 7. Where is y equal to 2, in other words? Well, y is equal to 2 in a couple of spots, here and here, right? Because this is where y is 2. So it happens at 2 spots, when x is 0 and when x is 1, 2, 3. That's supposed to be a 0. What is the largest output value, right? That means y value of the function. All right, well, your largest output is right here, and that is 1, 2, 3, 4. Okay, at what x value does this hit? Well, when is this 4? When x is 1. All right, hopefully we're good so far. All right, let's try another example here. So based on the graph of this function, so this one's called g of x, this is a curvy graph. All right, evaluate each of the following. All right, we can do this. G of -2, so I'm going to find -2 on my x I'm going to read down 1, 2, 3, negative 3. G of 0. Here's 0. I'm going to read down. That one's also negative 3. G of 3. 1, 2, 3. This time I have to go up, and that's at 1, 2, 3, 4. G of 7. 1, 2, 3, 4, 5, 6, 7. That's 0. Okay. For what values of x do we get 0? So that's where it's going to cross the x-axis. So we have a bunch of them. We have 1, 2, 3, 4 this time. All right, so those are at negative 1, 2, 3. They are at 1. At 1, 2, 3, 4, 5. And I believe this one up here was also the 7. How many values of x solve the equation g of x equals 2? Well, that's saying, I'm just going to erase some of this. When y equals 2, how many times does it hit the graph? So here's y equals 2. So how many times does it hit? 1, 2, 3, 4. 4 times. How can you illustrate your answer on the graph? I just did that, right? At a line y equals 2, g of x intersects at 4 places. Okay, it didn't ask for them because they don't cross nicely. That's why they didn't ask for what values of x it was, like they did in the first one. All right, hopefully this makes sense. It's just picking out and reading information. All right, any questions? You guys know, bring them to class. Have a good night.